Hi friends, in this video I will explain the concept of IPv4 datagram format for 7 marks. So first of all we need to know about IPv4 datagram. Packetizing is a primary service provided by the IPv4. It defines the format of a packet called datagram to encapsulate the data from a upper layers. An IPv4 datagram is variable length packet with header of 2 to 60 bytes and payload data. So in this the IPv4 datagram which will be containing onto the two main parts. First is the header and then payload. So as previously we have told that header which will be containing onto the 2 to 60 bytes contains control and routing information, and then payload is nothing but a data. The actual data being transmitted from a upper layer, example TCP and UDP. So here we will be having the IPv datagram, and then which will be containing onto the header and then payload. So next we need to write this diagram IPv4 datagram format, which is going to contain the several various fields. So before discussing with respect to this IPv4 datagram, we need to know about what are the legends. So VR which is going to indicating a version number, SLAN which is going to indicating header length, and then byte which is going to indicating a 8 bits. So the first field which is going to indicating onto the version field. So as the name itself it is going to indicating which is going to having a IPv4 version. So IPv datagram structure which will be containing onto the 20 to 60 bytes in a length contains a crucial field to ensure the proper routing and then handling of the packet. So which has been shown in this the figure. So and then payloads which will contain the data from upper layer protocols such as TCP, UDP and then other transport or maybe network protocols. So here we will begin with respect to the IPv4 datagram format. So here the size it will be the 0 to the 31, which means what 32 bits it has been present. The first field which is going to indicating specifies the IP version. So in this we will be indicating as a IPv4. So next SLAN which is going to indicates the header length. So length of a header in a 4 bytes word. So 4 to 8 bytes it has been present, which is going to indicating under the 4 bytes word, and then which is going to helps to identify where the header ends and then data it will be begins. So next service types it will be containing under the 8 bits. So originally it is called as a type of a service, shortly known as a TOS. So now it has been redefined as a differentiated services. Next the service type. So in this the service type the originally it is called a type of a service, now it can be differentiated services are present. So shortly known as a DIF service. So using for a prioritizing different types of network traffic. So this service types it has been utilized for a different types of network traffic. So examples voice over IP. So like that we can indicate onto the or use the several application in this service types. Next total length, which is going to specify the total length of a datagram including the both header and then data in a bytes. So which is going to helps receive the distinguish between the actual data and may padding that might be added. Next the fields are identification. So identification flags and then fragmentation offset. So these three fields which is going to indicating within that used for fragmenting datagram that exceeds the maximum transmission unit. So it is going to shortly known as a MTU of the network. So next which is going to allows the reassembly of a fragmented packets and its destination. So this which will be having the what flags the don't fragment flag D and then more fragments and then don't fragment flags are present. So and the next which is going to having the fields of the time to life. So it is shortly known as the TTL field. So which will be containing onto the 8 bits. So limits the number of hops a datagram can take. So each router decrements this value, and if it reaches to 0, the datagram it has been discarded. So prevents the datagram from endless circulating due to the routing errors. So next which will be having the protocol, so which will be containing onto the protocol of the encapsulated payload, example TCP and then UDP. So ensure the correct upper layer protocol receives the data at the destination. Next we will be having the header checksum. So header checksum used to verify the integrity of a header. So during transmission it should not be altered. So each routing recalculates the checksum since the fields like TTL changes with every hop. Next, as we know that source IP address, which will be having the original the source IP address, and then destination IP address, which will be the receiver IP addresses, and then option plus padding, which will be having the 0 to 40 bytes. So option fields used in the network testing, debugging of special features, and then adds the flexibility, but may require routers to recalculate the checksum if the options it has been altered. Thank you.